Okay, so we've started recording. Good morning. This is Weather and Climate, Geography 3500, and I'm Dr. David A. Padgett. Today is February the 4th, 2021, spring semester at Tennessee State University. So, just to make sure that we are all on the same page, I'm going to go to Student View and we're going to take a look at where we are this week. So this week we are continuing with the weather data mapping GIS exercise. And so the plan is for you all to take some of the data that you collected yourselves and also data that I provided from globe weather stations and convert those into ArcGIS Online, Geographic Information Systems, um, data visualizations. So that is the plan. So let's go to the first part of the assignment, which is creating data visualizations with the globe weather data collection sheet using ArcGIS Online. And so what we have done there is what you should do in order to build this data table is go into the assignment itself, and uh, there is a shared outdoor weather data collection spreadsheet that should be open to everyone. So we have data from uh, Ashley M or M Ashley and Garrett Ross, that are taken from the assignment from week one. And so uh, Theodore, are you able to access the spreadsheet?
Yes, but right now where I am, I can't really access it. But when I get home, I can access it and put in my data right away.
Oh,
But I have
excuse me.
my data here too. I can tell you to and then anything.
Oh, you said you're not able to access the shared spreadsheet?
Yes. I tried it on my phone and it wasn't really showing up.
Oh,
So
on
I
the
was,
phone.
yeah.
Yeah, it might not.
Yes.
You'd probably have to down. Well, anyway, well, this is what everyone in the class should be doing. Uh, so let's just use Theodora's and so what's are you in Accra?
Yes, I'm in Accra.
So that's where you took your measurements?
Yes.
Okay.
And that would be East Legon.
Excuse me?
East Legon. I can spell it for you.
Okay. I'm ready.
EAST LEGON.
LAGON.
No, E as an egg.
LEGON.
Yes.
Okay.
And
What was your latitude?
The latitude, come on, hold on. Please give me 1 second.
Oh, that's fine.
Latitude is 0.14115492.
So you said it's, say that again, 0.
0.14115492.
And
longitude is 5.654111762.
okay, that's
Then current temperature, what that time it was 33 degrees Celsius.
okay. Okay, so obviously you wouldn't have a National Weather Service station in Ghana. What was your cloud cover percent?
It was like between 10 and 25. Is it 20 or 25?
Yeah, we'll take the lower range.
Okay.
And what kind of clouds did you see?
It was is it isolated? Is there anything like that? Isolated.
Oh, isolated. Do you know what type of clouds? Was it altostratus, cirrus, any of
Okay, hold on. Let me check the chat real quick because I didn't really get that part.
Or whatever you can
But
kind of.
I took pictures and I'll just like look at the chat. It was more like cirrostratus.
Cirrostratus.
Yes.
Okay. You know approximately what time of day it was?
3 p.m.
That is local time.
And the date was yesterday, so it's 3rd February.
Is it the 3rd?
Yes, please.
Yes. So everyone should have access to this shared document so that we can get data into the spreadsheet so that we can create maps. And so I think that pretty much
Dr. Padgett,
yes.
I think I mixed up the longitude and latitude.
Okay. So you're saying that
yeah, it's the other way around.
oh, okay, so this should be okay. Well, so hopefully those of you who are watching this recording are able to follow what we just did. So go to the Dropbox folder, go to this outdoor weather data collection sheet, and then I'll demonstrate this again. Just click here, fill out the data, then you'll want to do File, download to Microsoft Excel. And I demonstrated this already on Tuesday, but I'll go ahead and do it again because I'm curious about something today. So from here, just want to save it. And so I have the outdoor weather data collection sheet, GEOG 3500, demo 2. So this is the second time I'm demonstrating this. Save it. Then we want to do File, Save As, and then we want to save it as a CSV comma delimited file. And you're going to get a lot of strange errors. Don't worry about it. Then we want to close that file. Same thing, a lot of strangeness. Just keep hitting yes, yes, yes. Then you go to your ArcGIS online account, sign in, go to map, and so you should get a blank map like this one. And then you can just simply add layer from file, choose file, go to that sheet we just saved, the CSV file, import layer. And this should be interesting. Okay, so we can look at where I'm going to hit done and then go to the legend. So here are students, and let's see. So we have well, clearly our latitude longitude is off a little bit, but it is at least near Accra, and that could be for a variety of reasons why this is out here. But
I'll check and fix it.
Yeah, that's fine. Like I said, what did you use to get your latitude and longitude?
Where I'm at up. Where I'm at up. The app that you said we should use.
Oh, you used the where I am app, and it kind of put you out here in the ocean. I mean, that's that's one way that you could do it. If you can, you could also use Google Maps.
Okay, I'll use Google Maps and change it.
Use Google Maps. And so you said you were, this just illustrates why we use attribute data. So we can go to the attribute table, and as you can see, it says East Lagoon. So let's see if we can find that. Oops. Oh, there it is, East Lagoon, Accra, Ghana. And so you were somewhere in here, Theodora?
Closer to A, do you see A and C?
Oh, somewhere around here?
Yes, somewhere around there.
Okay, so then you could just drop a pin here. And you'll notice at the bottom of the screen, you have the latitude. Oh, I see what happened. So your longitude should be a negative number. And
Oh,
that's,
okay.
yeah, that's all it took to throw you off a little bit. So if you go back in and make that number uh, negative, then the longitude, then you should be okay. Let's see, yeah, because the latitude is about right. It's that the longitude should be a negative number. And so you're just barely in the Western hemisphere, just barely. So you can actually, probably we can just take the data that you have, and then we can just make this a negative number. Hopefully it'll hold up. And, oh, good, it didn't go. So now we make that a negative number. That should be close enough to where we dropped that pin just now. Yeah, that's close enough. I mean, we don't have to be exact. So this is how we can use Google Maps to get latitude and longitude in the event that we're wondering what happened. But so again, we want to populate this spreadsheet with data from assignment 1. And so I'm going to stop the share for just a second here. Well, no, I'm not going to stop the share. I'm going to go here, and I'm going to go in as developer because I'm going to extend the deadline for the assignment 1 to February 6th a little bit, just for those who haven't completed it yet. But again, if you have completed this assignment, then please do so. Okay, so what we need to do is, again, get as many of us to complete this assignment as possible. Excuse me, to add to the spreadsheet as possible. And then go through the process of creating the map using the class data. And again, that should be done by 9 o'clock in the morning this Saturday. So I've already demonstrated how to create the map itself, and that should not be impossible. Looks like we have another issue though here while we're at it. Let's see. Ashley's data is not showing up. Now let's see what's going on there. Don't see anything wrong there in the spreadsheet. It might be in this spreadsheet. Don't see anything wrong there either. So let me go to File, download Microsoft Excel. Try to figure out what's going on here. Oh, I'm going to enable editing. I'm going to change the format of these cells to, I'm going to go to format cells number to see if that's what's wrong. Push this out to 7 places past the decimal, maybe 8, just to give some uniformity to our data. I'm going to put all this in the same font. Like I said, I don't know what could possibly be a problem here, but so I'm just going to choose a new font. And so I'm going to do File, Save As, and this is going to be Demo 3. As an Excel spreadsheet first. And now I'm going to try to save it again as a comma delimited CSV file. And so this is the same procedure you'll have to go through in order to save your data set. So essentially what we're going to have is a database that is going to be built by the class as a collective. So now you just go to your ArcGIS Online account. And sign in. Go to your map. Add search, oops, excuse me, add layer from file. And there's demo 3. Import layer, and let's see. So for some reason, Ashley's data is not showing up. I cannot figure out why that is. All right. It's not that. So here we have, oh, wait a minute. Aha. So I see what happened. That's strange. How could they? Oh, they're both there. I have to zoom way in. Okay. Okay, so here we have everybody's data. Thought there was a mistake. So there's Ashley's data. He was over by the new resident complex. And Ross was over by the new health science building. So in your analysis, you should then write detailed answers to the following questions. So hopefully by tomorrow, we will have ample data added to the shared spreadsheet for us to have a full class of data on the map. So far, We have 3 students' data here. So the rest of you all, as you watch this recording, just follow that procedure to get the data on the map. Now, of course, in answering the questions, then you can simply, you can do several things. You can change the symbology. So let's look at the, if you go to content and go to the layer and find the change style button, change this to say current temperature digital, and then hit done. Now we can see differences in temperature collected at each location. So we have to zoom in kind of close. So it looks like Ashley got 3.3 degrees Celsius, but notice that that was on January the 30th, whereas Ross was outside on a different day and got 16 degrees Celsius. He was out on the 26th, and we went and checked our data, and certainly those are accurate measurements. So now if we zoom out, and so we have an interesting case here where we have Theodora, who is in Ghana. So I corrected that. Corrected the longitude, and yes, so now we see that Theodora's point is here. And so if we click there, we get 33 degrees Celsius, which is getting close to 90 degrees Fahrenheit, much warmer. But if we zoom all the way out, we can clearly see why that is, in that the equator is approximately here. And so Accra is at a significantly lower latitude than where we are. And so it's in the tropical region of the world, lower latitude, about 5 degrees north of the equator. And yeah, about 5 degrees north of the equator here. Let's see, she's exactly at, yeah. And so if you think that every whole degree of latitude is about 70 miles, so she's about 350 miles north of the equator compared to where we are, which is much farther. And so latitude is one of the main climate controls. We'll talk about climate controls later on. But in answering some of these questions, okay, cloud observations and current temperature observations, you can see that cloud cover percent was only 10% for Theodora, and she saw cirrostratus. It's very, very warm and clear day that day. And of course, we had some different situations happening here on TSU's campus, but you can clearly see the difference in temperature here. Is there a different, what about current temperature and land cover? Of course, we can change the base map to imagery, so we'll get a better idea of what the land cover is like here in Accra. And so it's like the land cover, keep zooming in. It's a very much urbanized area, lots of rooftops, lots of streets, not a lot of vegetation, And so we would expect that the albedo of the surfaces, and of course lots of concrete absorbing that incoming solar radiation, is going to result in subsequent long wave energy radiation warming up the atmosphere. So there are a couple of obvious reasons why we would see differences in temperature at this spot versus the others. Then look at some of the other atmospheric properties. Is there any data of specific significance in terms of incoming solar radiation or anything? Is there a big difference? Is there anything that might have an influence upon the current temperature in cloud observations? You might have to do some research there, and then what did you learn? So those are the questions that go along with mapping the data that we collected as a class. So next is the data visualization with the Detroit area Globe partner schools. And so these are the data that come from the Globe schools in the Detroit area. And so what I've done is I have actually provided you with those data. And so that is as posted along with the assignment. So I'm going to view as student. So when you go into the assignment for weather data mapping, you'll see the Detroit and Toledo area current temperature data. So you'll take that. And so notice that I've already built this spreadsheet for you, or at least I demonstrated how to build the spreadsheet last time using the large databases that we pulled off of the Globe websites. And then we calculated the average temperature in degrees Celsius at each of those weather stations in the Detroit, Toledo area. And now your task is to follow the instructions to take this table and you will do exactly what we did with the data that you collected yourselves, but we're going to take the Detroit area Globe Partner and Schools data, pull it into the ArcGIS Online map, and that's what's in these instructions. And then you will go through the process of following these instructions. And don't worry about these figure numbers. I'll probably take those out. What I'll probably do is when we get to the final demonstration of this, I'll pop in the figures then. But for right now, just don't pay attention to those figures. That'll be done later on. And of course, afterwards, you should, again, follow these instructions and answer the questions in a detailed answers to each question. So last but not least is you're going to create a story map using climograph data. And so I have here, so what are climographs? Climographs are really another way to say it is climate graphs. And so here are a set of climate graphs for Detroit, Michigan. So a climate graph is a graph of temperature and precipitation, and usually they're on the same graph. But here are, and these are average temperatures for each month in Detroit, measured at some weather station over a period of years. Usually it's at least 20 years, sometimes it's less. But usually you have a good 30 years worth of data, and you would record and then determine the average temperature for January, in this case, high and low temperature across that period of time. And we'll talk about, oh, here it is. It actually has it here, 1971 to the year 2000. So from 1971 to the year 2000, for this weather station in Detroit, these are the low and high temperatures observed over that 30-year period or so. So that's an example of what a climate graph is. So what you're going to do is go to the Globe website, and I'm going to demonstrate that now. And we're going to go to the Globe website, or you are, and just following these instructions. So we're going to go to the Globe website. Go to globe.gov. And the next thing you should do is go to the Globe visualization system. So you go to visualize data, then enter the visualization system. And so what this is, these are visualizations of globe data from all over the world, literally. Okay, so what we want for our observations, we want atmosphere observations. We want to look at daily air temperatures. So that's the main thing that we want, our daily air temperatures. And so then hit submit. Now notice the dates. We don't have the dates that we want. So we go to data counts, and it takes a little while for this server to catch up. So we'll just give it a couple of minutes to load, and then we'll put in the dates. So the dates that we want are for summer are from June 2019 or we can type it in this way, 2019 06 01 to 2019, and you just have to play with it a little bit. It is kind of a pain in the neck. Okay, to 2019. And I do 09, 01 just so we get complete coverage of August. And then that's going to take a couple seconds. Okay, so now we have air temperature data for June through July of 2019. And so just have a little patience as you zoom in. It's going to might be kind of clunky. If you have a slow server, you might have even more difficulty. And so if we continue to zoom in, then we'll see the larger point symbols represent the schools that are in our database. And so we know that the schools in our database are Crestwood High School, Hearn Valley High School, Shoemate Middle School, Grosse Isle, Wayne County, Ressa, and so on and so forth. Okay, so what we want to do is go to, let's see, this first site. Okay, this is Wayne County Math and Science Center. Let's go to a custom view. And so we want to look at 2019 6-1. Right now we have a much larger, so that's what we want there, 0601. Plot it. We want to go to measurements. And it's going to take a couple seconds. Okay, so now we have air temperature from well, looks like air temperature from the, okay, I'm gonna have to switch that up again. It didn't quite give us what we want here. So, and you just have to play with it a little bit. For some reason it didn't do what it was what I wanted. We want 2019 06. Maybe that'll do it. And now I'm going to plot that again. Okay, now we have June through August 2019. That's what we want. Notice there's a little break in the data. Maybe the weather station was down. Maybe there was a electrical shortage. So here we have our plot. And so there are several ways that you could possibly get these data. You can do it that way, that. And then if we print to a PDF, save as PDF, and then we'll have, the data for have it's Wayne County. Climograph. June 1 through Sept 1, 2019. And so now we have our data from one of the stations for that range. Now, we saved that in PDF format, which really will only partially do what we want. What we really want to do is capture this climograph. So there's two ways you can do that. You can do a print screen and simply just paste the whole thing. Well, actually, you have to do a print screen, and then you'll have to find a way to save it. The easiest way is with a program called Paint, and just paste that in there. Zoom out, and then all you want is the climograph, and then crop that out. And now we have it saved as a JPEG. So file, save as JPEG picture, documents, TSU docs. I'm just saving this along with my other stuff for your class. And now we have, Wayne County RESA site. Now we have that saved as a JPEG. And so what you'll do is follow the instructions and save all of the climagraphs just as I have there. Then you have to create a Flickr account. Let's see. This is where it's going to get a little bit tricky. And I think I have, see if I can remember my password. Try one more time. Now, go forgot password. I wonder. Let's see. That's not it either. Maybe I don't have an account. Maybe my account expired. But anyway, you'll sign up for a Flickr account. Okay, I'm going to stop record for a second here or pause it. Okay, so what I'm going to do is I'm going to, outside of class time, work through this Flickr account issue, and then I'll post that in a second recording for you to use as a guide until I figure out what's going on there. But in the meantime, you should be able to do the first two maps fairly easily and then answer the questions. And again, try to have that done by try to have that done by, well, not try, the deadline is February the 6th at 9 o'clock in the morning. And so at that time, we will share your work with the high school students. So I have a project in Detroit. I'm working with Detroit area middle and high school students who are participating in a Saturday science program. And so that program runs from 9 o'clock till noon Eastern time on Saturday. So I will send you the Zoom link as soon as I have it. And so what we are doing as part of this service learning activity is having these high school students engage with you. And so you will in large part be serving as role models. These students are studying weather and climate just like you are, except they're in high school and you are in college. And so this is a what we call a near peer learning activity for the young people. And so we hope that they will be inspired by you to seriously consider studying weather and climate in general, or science, technology, engineering, and math specifically. Okay, so I'm going to stop the recording now.